Let's talk about device under test we'll be using for Jumstart ASIC verification course. We'll be using two DUTs. First one is calculator and second one is UART. And we'll be simulating both of these DUTs exhaustively with Questasim simulator from Mentor Graphics. Right. So calculator DUT, it has a standard clock and reset inputs. It has two 8-bit inputs, A and B. It has a control input which defines the operation type as defined in the table. It supports addition, subtraction, multiplication and division. It also has an output of 16-bit which is defined with C, and it has a, for data inside, it has a data valid and stall output, as well as on the data outside it has a data out valid and stall input to support data valid stall protocol. The second DUT we are using is UART DUT. Again, it has a standard input clock and reset. It has a host interface. It's a standard Motorola host interface, and it has an interrupt output. Also, it has a serial data in signal called RXT. The serial data in signal pushes the data serially, and you can read that data through the host interface in a parallel interface. Serial data input follows the standard UART protocol for the receive. It has a start bit, 8-bit of data and stop bit. Once a serial data input goes into the DUT generates, when DUT converts into the parallel data, it generates an interrupt. And once host receives an interrupt, host can issue a read transaction to read parallel data from the DUT. Let's talk about the final project. As a part of the final project, we want you to build a test bench or verification IP for one of the complex protocol. If you want to go on a simpler side, then you can choose I2C slave. If you want to go on a complex protocol, then you can choose either Ethernet MAC or DDR controller. These design IPs are provided by Atria Logic.
And thank you, Bhavin, for the review of our various device under tests that we provide. So I will now go over the calculator, which is instantiated in a simple test bench. And we'll walk a little bit through the test bench code and then run the simulation and show you how to use Questasim to debug it. So first we'll start by going to where I have an example of that test bench. So this is my directory where I have this model. So I've been doing various things in here, but I'd like to point out that we have two Verilog files. We have design.v and tbtop.v. Design.v is the Verilog code for the calculator. tbtop.v is the test bench for the calculator. So we will look at that now. As you can see, we always start with a module. We have a clock, reset, valid, the two inputs A and B, the control bits that tell what the type of whether you're doing addition, subtraction, multiplication, or division, and then the outputs. There is the instantiation for the calculator. Here is the initial code that implements the clock. And then this is where our test case is. We start with initializing signals and then resetting the device under test. And then we do we're going to then do an addition of A and 5 and 5. Then we're going to do a subtraction from 5 from 8. And then we're going to do a multiplication of 7 and 11. And then we're going to do a division of dividing 16 by 2. And these are all in hex. And then we finish the simulation. And here is the task that we use to actually read and write the calculator. As you can see, we use display code to show you the what's going on. Then, as you can see here, we use a case statement to decide what type of a transaction the test case is trying to do. So if it's the input control signals are 0, 0, then it's an addition. If it's 0, 1, it's a subtraction. If it's 1, 0, multiplication, and 1, 1, making sure we're not dividing by 0, then it will do the division. And then here is the rest of the code that is used to drive the inputs, and then it waits for the valid signal, registers the output, and then disables the input valid signal, and then it checks the results. And then we have the task, as I noted earlier, that used to initialize the signals that go to the DUT, and then here's the reset sequence. And then it's the end of the module. The other thing I have for this example is the run script. So let's take a look at the run script. Every time I run this script, it basically cleans up any leftover files from before. It initializes the work directory. This is a requirement of the simulator. It then compiles the code, gives you the time scale, and then I include at the end design.v and tbtop.v. And then if I want to run the simulation in an interactive mode, I use an argument of waves, and otherwise it just runs the simulation in like a batch mode. So let's do that first. And I just simply use run sim.cs. Okay, so as you can see, the first transaction is A is 5, B is 5, and the control is 0, 0, which is an addition, and expects the output to be A, and it got A. And the next transaction is the A is 8, and B is 5, and the control being 0, 1 says it's a subtraction, and it expects 3, and it gets 3. And then the next one is 7 and then 11 with 1, 0, which is then multiplied together, and expects 7, 7. And then the following one is 16 divided by 2, 16 hex divided by 2, and it expects the result of B. And then it finishes. So now let's run the simulation in interactive mode. So I'm just going to run the last command with the argument of waves. Okay, so this is what the interface is that you'll see. So I'm going to really just focus on how to quickly start debugging. So as you can see, we have basically the top level and the instantiations in the top level. So what I'm going to do is actually debug through the top module, the tbtop. So double click on that. And now you can see the source code. And really all we need to do is to see these main signals. So let's start by bringing in the clock. Okay, so you see this read only. Turn that off. And we're going to try this again. Add to wave. And now you can see the clock. It's X because the simulation hasn't started running yet. This just gives us the opportunity at the beginning to put the signals in. So we're going to go back to tbtop, and we're going to put in the reset. And we'll just continue through with all these signals. Okay, so now we have the interesting signals in our waveforms. So we should see the the clock run, the reset sequence happen, and then we're going to see the A and B inputs asserted and the valid signal along with the control signal, and then we're going to see the outputs from the DUT. So let's go ahead and simulate, and we're going to run for 100. We won't see all the 4 transactions, but we'll look at the first 2. And so now we're going to zoom in. So as you can see, we see the clock running. And then here's the reset signal. So basically the first pound 15, it's high. Upon 15 it's low, and then it goes back high and stays high. So now it knows that the reset sequence is done, and the DUT is in a state that we can start to use it. A few clocks into the simulation, the valid signal goes high, and the task, the calc read write task, drives 5 on A and 5 on B, and you can see them here, and you can also see them here. And the control bits are 0, 0. One cycle later, the output comes, and you can see that the result is 1, 0, 1, 0. So we'll scroll a little bit more. And then the data from out C goes to got C. One cycle later, it's transition off, and then remember the I valid goes low. And then we have a couple clocks, and then the next transaction starts up. And at this time, A is 8, B is 5, and we're going to show, as you can see, we're doing a subtraction. And the result is then 3. I hope this is a good starting point for you to use Questasim and a little bit of familiarity with what a test bench code would look like for the calculator. We also have the user guide for Questasim available in the module of user guide and reference manuals. To find it, you can click on the table of contents and for Questa Simulator reference manual. So on behalf of Bhavin and myself, we'd like to thank you for watching this video. So if you have any questions, feel free to call us at 877-748-1708. You can email us at info@verifasttech.com, and you can find us on the web at verifasttech.com. Thank you so much. Have a great day.